This lesson goes on to finding areas of sectors and areas of segments, and it links with chapter 5.3 in the year 13 or in the year 2 pure maths textbook. So let's have a look how it fits in with what we've done already to do with that chapter. We've looked at radians, their definition, and how we can convert between degrees and radians. Last lesson we looked at finding arc length, so that's a fraction of the circumference when the angle is measured in radians, and then today we're going to go and find areas of sectors and segments when the angle is measured in radians. Okay, so here's where the notes start, so you should start writing these down. So let's look at the area of a sector first. Now what a sector is a bit like a slice of cake. Okay, it's a portion of the circle that's made up by 2 radii. Okay, so the size of the sector is defined by the angle it makes at the centre. If you think about how you would find the area of that sector, it's a certain fraction of the area of the whole circle. The area of the whole circle is pi r squared. The fraction that the sector is, if it was measured in degrees, it would be theta degrees out of 360 times pi r squared. So let's do the same as what we did last lesson. If theta is now in radians, okay, the 360 becomes 2 pi. So you get theta over 2 pi times pi r squared. The pi's cancel, so you end up with the formula for finding the area of a sector is half r squared theta. Now this is not given to you, okay, so you do need to learn this. So remember, the arc length is r theta. When theta is in radians, the area of a sector is half r squared theta. Okay, so that's a sector, and we'll look at some of those in a minute. Let's have a look at a segment then. Now this is a segment. Can you see this shaded region here that's marked A? That's a segment. Now I like to remember a segment as it's a bit like a segment of an orange. Okay, so that's the shape it makes. If you have a look at how that segment is made up, or how we could calculate the area of it, we can see if we join the line between P and Q there, okay, we can find the area of that segment by finding the area of the sector, take away the area of the triangle. So that's what we're going to do here to come up with the formula for it. Okay, so area of a sector half r squared theta, we just did that. Area of a triangle, now it's not a right angled triangle, so we're going to use half AB sine C or half AB sine theta. Okay, now if we look at A and B, they're the sides that make the triangle with the angle between, so they're both radii. Okay, so that formula becomes half r squared theta for the area of the sector, take away half r squared sine theta for the area of the triangle. We can factorise that by taking the half r squared outside. So the area of a segment is given by this formula. Now, to be perfectly honest, I don't learn or remember that formula. All I would do if I'm going to find the area of a sector is I would remember how to find the area of the sector. So if I wanted to find the area of the segment, this is a segment formula, I would find the area of the sector using my half r squared theta, and I would subtract from it the area of the triangle, which I remember as half AB sine C. Okay, I'd do that really rather than using that particular formula. Okay, I don't like to remember too many things. Okay, so area of a sector, area of a segment, 2 things you need to know how to do. Let's do some examples then. Here's my example number 1. So pause this video so you can copy it down. So a plot of land is in the shape of a sector of a circle of radius 55. The length of fencing that is erected along the edge of the plot to enclose it is 176 metre. Calculate the area of the plot of land. So there's no diagram drawn here, so I would always, while I'm thinking about my question, I would always draw my diagram. Now here's going to be my plot of land. It said, it said that it's a sector, so I'm going to draw myself a sector like that. Radius 55, so let's mark on that that's 55. Okay, and the length of fencing, well, let's have a look at what the length of fencing would be. The length of fencing that encloses it is that, and that, and that. Okay, so we are going to need to know what that angle is there. We don't know it at the moment, so let's call it theta, and that's what we're going to need to find out. So what have we been given? Make sure that we show our working nice and clearly. We've effectively been told that the perimeter of it is 176 meters. Now, what's the perimeter made up of? Well, it's made up of a radius, and an arc length. Okay, so we're going to need to form a bit of an equation for that. Okay, now we know what the radius is, we know what the radius is, we don't know what the arc length is. Okay, so if we call the arc length x, then the perimeter is 55 plus another 55 plus my arc length x, and that equals 176. So that tells me that the length of x must be 176 minus 110, which is 66 meters. Now, because we know the length of that arc, remember the formula for the length of an arc is r theta, so we know that r theta must equal 66. But we know what r is because that is the radius, so we get 55 theta equals 66. Or we get theta equals 1.2 radians. Okay, that's all very good. Let's see what the question was actually asking us to calculate. Calculate the area of the plot of land. So we now need to use this theta to work out the area. So it's an area of a sector. Write your formula down, half r squared theta. Do remember the half. Okay, so that's a half. Put your values in, 55 squared times theta 1.2. Remember, never type anything into your calculator that you haven't typed down. And that comes out as 1815. Check for any accuracy. No, they've not asked for any accuracy, so I'll just leave it like that. Units, it's an area, so meters squared. Okay, so working nice, clearly shown there. No diagram was drawn, so I've drawn myself a diagram. Okay, and then that just helps to make sure you're working through the problem and understanding what you're doing. Okay, question number 2 then. All right, so the diagram shows a sector of a circle. Find the area of the shaded segment. So this is the area here that we want to find. Remember, a segment, okay, like a section of an orange. Okay, now we do have our formula, but as I said, I don't generally use the formula. What I do is I do the area of the sector first. That's half r squared theta. Theta is in radians, so that's a half times 7 squared times 1.2. Okay, I can stick that in my calculator if I want, and I get 29.4. Then I do the area of the triangle. Formula, half AB sine C. So relative to this, that's a half times 7 times 7 times sine 1.2 radians. Make sure your calculator is in radians mode. Okay, and you get 22.8349 dot dot dot. And I'm going to leave it like that because I'm going to use that value in a minute. So then the area of my segment, okay, is equal to area of the sector minus the area of the triangle, because remember that gives you that shaded region that they're after, use that exact value in your calculator, do 29.4 minus answer, and no accuracy specified in the question. Okay, so 3 significant figures is good if they don't ask for anything. Units, it's an area, and my lengths are centimetres. So, okay, centimetres squared. Okay, so as I said, you don't necessarily need to remember the formula if you don't want to. I mean, it's a half r squared brackets theta minus sine theta. So if you want to remember it, of course you can use it. Half r squared theta minus sine theta. But if you don't want to remember loads of things for your exam, just remember what you're doing. Area of the sector, you do need to remember that. Minus the area of the triangle, half AB sine C, you should all remember that. Okay, right. One more then. Okay, example number 3. So if you'd like to write that one down for me then. Make a copy of the diagram. Okay, and this is a bit more of a general question, which people can typically find a little bit more difficult to do. It's to show that. So ultimately, this is what we want to show. Okay, so we've got to show our steps really nice and clearly because they've effectively given us the answer. Okay, now I know they've given you a nice diagram there, but there is some really important information up in the top here. Given that the area of the triangle AOC is 3 times that of the shaded segment. This is the shaded segment in case you can't see it, it's that little bit there. So the area of AOC is 3 times that. So we're going to need to make use of that in our question. Okay. Right, so let's start forming some expressions then. Now it talks about the area of the triangle AOC. So let's write an expression for that. So area AOC. Okay, it's a triangle, half AB sine C. Okay, well, let's have a look at that then. Well, the angle that we have within the triangle is there, and that is going to be pi minus theta, because it's on a straight line with theta. The whole straight line is 180 degrees or pi, so that is going to be equal to a half. A and B are both r, so r squared, and then sine pi minus theta. Now we'd like to simplify that a bit. So what you need to do is remember about sine and what the sine graph looks like, or think about the cast diagram. If we were to draw a cast diagram and we were to draw theta there, pi minus theta would be there. Okay, C-A-S-T. Well, actually sine is positive here. It's the same angle, so that is actually the same as half r squared sine theta. Okay, or you can think about the graph. All right, the sine of pi minus theta is the same as sine of theta. I prefer the cast diagram then. Right, area of the shaded segment. Well, let's form our equation for that. Area of the segment. Okay, it's the area of the sector, half r squared theta, minus the area of the triangle, half AB sine C, or half r squared sine theta, because that's the angle that makes up that portion. Right, let's form our equation using the information that they've given us here. The area of the triangle is 3 times that of the shaded segment. Okay, so the area of AOC equals 3 times the area of the segment. Okay, so let's write an equation then. Area of the triangle, half r squared sine theta. Area of the shaded segment, 3 lots of half r squared theta minus a half r squared sine theta. Okay, the thing we're trying to prove it has equal 0, so we're going to pop everything over onto one side. Okay, might just double it first, that gets rid of these halves, so we get r squared sine theta, multiply out the brackets, 3r squared theta minus 3r squared sine theta. Now we can cancel out the r squareds, reason being r is not equal to 0. Okay, so they can disappear. Let's pop it all on one side, so I'm going to collect it over that side. 0 is 3 theta, we've got rid of the r squared, 3 theta minus, okay, I've taken a sine theta over, so I end up with 4 sine theta. Okay, and that gives us what we want. Just write it the other way round, 3 theta minus 4 sine theta equals 0. So a question that typically people might find a little bit difficult because it's very general, there's no numbers in it. Okay, this was an interesting bit to make sure that you understand. You've got sine of pi minus theta, but make sure, as long as you understand your cast diagrams, then that should be fine to work that out. Okay, so make sure you've got that all written down. Right, final example. Oh my goodness, a challenging exam question. Okay, so I'm going to give you, well, you're going to pause this, okay, and you're going to copy that down, copy down the diagram, 12 marks. So there's going to be quite a lot going on here. All right, so we're going to have to show our working nice and clearly, and we've got quite a lot of information going on here as well, which we're going to read through as we copy it down. Nice diagram, okay. So a sector of a circle with centre O, radius 10, so the whole thing is 10, POQ 0.3 radians. They've marked all of that on. Right, here's the next bits. Okay, so they've not marked this on, so the point R is on OQ such that OR to RQ is 1 to 3. So we know that that whole length OQ is 10 because it's a radius. So if OR to RQ is 1 to 3, that means that this is 1/4 of it and this is 3/4 of it. Okay, you think about how your ratios work. So that's 1/4, that's 3/4. We know the whole length is 10, so that enables us to work these bits out. So this bit here then, 1/4 of it is going to be 2.5 centimetres up to here. Okay, and then this bit, 3/4 of it is going to be 7.5 centimetres. So we can make use of those in our calculation. So that's using the bit of information that's in the question. So that shows you how important it is to read the question carefully. Okay, so let's crack on with part A then. The perimeter of S. S is the shaded bit. The perimeter of S, okay, is made up of 3 bits. Okay, it's made up of the length QR, the length QP, and the length PR. Okay, it's made up of those 3 bits. Now let's see what we know already. Okay, QR, that's not a problem. We know that, that's 7.5. QP is an arc length, so let's work that out. So QP is an arc length, which is r theta, which is 10 times 0.3, which is 3 centimetres. Okay, so we have QR, we have QP, we need to work out PR. Now let's have a look at how we work out PR. Well, PR is part of the triangle PRQ. For the triangle PRQ, we know 2 side lengths and we know the angle between it. So hopefully what should be springing to your mind is making use of the cosine rule. Okay, remember what the cosine rule is then. So PR squared is equal to, so this is like your A squared equals B squared plus C squared. So it's the 2 side lengths we know squared, 1 squared plus 10 squared, minus 2BC, so 2 times 1 times 10 times cos of the angle between them, 0.3. Make sure you're in radians. We pop all that in your calculator in radians, 58.48 ... Okay, so PR is equal to the square root, 58.48. Do remember to square root, and don't round the value, use the exact value. So 7.647. Okay, so then the whole perimeter is all the bits added together. QR was 7.5. QP was my arc length, 3. And PR, 7.647. Read the question. 3 significant figures. Don't throw marks away by not giving it to the required accuracy. To 3 significant figures, 18.1 units, centimetres. Okay. So 6 marks, because we've worked out quite a few things there, haven't we? We've had to do an arc length. We've had to use the cosine rule to work out the side of the triangle. And we've also had to use our ratio part to work out what the length QR is. All right, so quite a lot going on there. So that's why that's 6 marks. Area of S. Okay, area of S. Now, it's a little bit of an unusual shape. Okay, but hopefully by looking at your diagram, you can see that the area of S we're going to get by doing the area of the sector. That's the whole thing minus the area of the triangle PRO. Okay. Right, so area of sector, half r squared theta. Okay, so half r squared theta. Area of a triangle, half AB sine C. Let's plug our values in. Area of the sector, half radius 10 squared, angle 0.3 in radians. Area of the triangle, half times, now just be a little bit careful with this, half AB sine C. It's not like when we're finding the area of a segment. Okay, the 2 side lengths are different. Okay, so one side length is 1, one side length is 10, and remember you use the side lengths that make the angle that you put in the sine part. Okay, all of that, and I can pop that in my triangle. Oh, it's not 1, is it? Look up at my, I'm looking at this 1 here. The side length there is not 1. The side length is 2.5. The ratio was 1. Sorry, that's my mistake. I looked at that 1 up there. So half times 2.5 times 10 times sine 0.3. You've got all of your working down nice and clearly, so you can just put that into your calculator now. 3 significant figures, 11.3 units, centimetres squared. That's the 3 significant figures because that's what the question asked me for. So again, quite a lot going on there because you're doing the area of a sector and you're doing the area of a circle, area of a triangle using the right lengths. Okay, so 12 mark question, that's quite a big one. So do make sure you understand that. If not, go back through and watch it again. Okay, right, over to you. You've got a reasonable amount of work to do. What I would like you to do first, please, before you do the homework assignment, is complete these questions from exercise 5D, 4, 6, 8, 10, 12, 14, 16. So you complete them, you mark them from the back of the book. If you have any problems with them, okay, either check out the work solutions or I will be going through them next week at our Teams meeting. Then we finish the arc lengths and areas of sectors. So there's a homework assignment 1, it's the year 13 homework assignment 1. So I've put that homework assignment onto Teams. I've also set up an assignment for you where you can upload your images of those. I've set that up on Teams as well. So I would like that submitted, please, by Thursday, 21st of May. Okay, so that I can then get that marked, okay, for basically after half term. It's the last week of term, isn't it? Yeah, so I'll get that back to you on our first Teams meeting on the Monday back. Okay, lovely. All right, so do watch that again if you're not sure about it, and do, as always, email me if you have any problems. Okay, thank you.